everyone, so for today we'll be working on the solution for problem set 3, which is runoff, less comfortable. So in this problem set, each voter gets to rank candidates based on their preference. If any candidate has majority, that is more than 50% of the first preference votes, that candidate is declared the winner. So for example, if there are 9 voters, the number of votes needed to win is 5 or more votes. If no one has the majority first preference vote, a runoff occurs. What is a runoff? So let's understand this by looking at an example that we have, where we have 9 voters. So to win the election based on the first preference votes, a candidate must have the majority of the votes. So in this case, it has to be more than half of 9. So for a candidate to win, he or she must have at least 5 or more votes. So looking at the first preference votes that we have here, you can see that Alice has 2 votes, Bob has 3, Charlie has 4. And since no one got 5 votes or more, a runoff occurs. So at this stage, because Alice has the lowest vote count of 2, she is eliminated. So we strike her name off from the voters' vote cards who ranked her first, and for these 2 voters, you can see that their next preferred candidate is Bob. So we will update the vote count now, where Bob has 5 votes and Charlie has 4. Since Bob has a majority of votes now, he is declared the winner. One thing to note is that there is a possibility of a tie. So what happens if everyone is tied for last place? Doing an elimination at this point will just mean you're eliminating everybody and you have no one left. So in such a scenario, instead of eliminating everyone, we will just declare a tie. Now before I move on, I just want to thank everyone for taking the time to watch this video, and I really hope that you can subscribe to this so that you'll be alerted when I post the other solution sets out. And yep, thank you so much for your support. Do continue to watch the video. So getting started, we do notice that they have given us the distribution code for this problem already. So let's go through the distribution code that we've been given so that we can understand what we already have and what we need to work on for this problem set. So for starters, we can see that the maximum number of voters is 100 and the maximum number of candidates is 9. And then we will also have an array called preferences, which is preferences, square bracket I, square bracket j, where I represents the voter and j represents the candidates. Okay, then moving on, each candidate has a name, number of votes, and the elimination status, which can be true or false. Next, the number of voters will be stored as voter count, while the number of candidates will be stored as candidate count. Then, we have a whole list of 6 functions, which will be what we'll be working on for this problem set. So moving on, when we run the program, we need to make sure that the user keys in a valid input, which would be /runoff followed by the names of the candidates. So if the user only keys in /runoff, that means that the argument count is less than 2, which means no candidate's names will key in. If this happens, we will print the error message. If the user keys in a valid input, the system will now need to check that the number of candidates keyed in is less than that of the maximum number of candidates that we declared earlier on. So in this case, the candidate count will be equals to argc minus 1. So why do we need to minus 1? So this is because if the user keys in /runoff, Alice, Bob, Charlie, the argument count is 4 because it includes /runoff. So for the candidate count, we need to minus 1 to accurately store the total number of candidates running for the election. Next, for each candidate, we are declaring that they will need to each have a name, which is argument vector I plus 1. If you need more explanation on why the name equals to the argument vector I plus 1, do check out my video walkthrough for the solution of Caesar, as we had covered it then. So for now, the number of votes per candidate starts with 0, and the elimination status is false because they are all running for the election and have not yet been eliminated. Next, we ask the user for the number of votes and validate it to ensure that it is not more than the stipulated number of maximum voters. So if it exceeds that, we will print the error message. So now we will get the user to key in the ranked preferences of each voter, depending on the number of voters and candidates there are. So for example, where the number of voters is 5 and the number of candidates is 3, you can see that the system needs to prompt the user for the first voter's ranked preferences, then move on to the next voter's ranked preferences, and so on. So to do this, we actually need to look through the number of votes and number of candidates. As the user keys in the names, the system will also check to make sure that the name key in matches one of the candidates' names. If it does not match, then we will print the error message to state that the vote is invalid. Next, we need to keep holding runoffs until we declare a winner. So in this case, you can see the 2 functions that we need to write, which would be tabulate to calculate the number of votes, and print_winner to, print the correct winner's name. Then we also need to write the functions find min and isTie, which will help us to write the last function, eliminate, where we will eliminate anyone with the minimum number of votes. So in summary, there are actually 6 functions to write. So let's work on the first one, which is called vote. So the purpose of this function is to actually keep track of all valid preferences. This will track the voter, rank, and name. And for every valid vote, we need to update the global preferences array, which is stored as preferences, square bracket I, square bracket j. And this is the section that we need to key in our function. So how do we do this? So for every vote made, we will need to look through each candidate's name, comparing their name with the name that the voter keyed in. If there is a match, which we will use string compare to do so, which we actually touched on previously in plurality, we will update the global preferences array. So after each voter casts their votes, we can put their names into the table as seen on this slide. So for example, the first voter, represented as voter 0, can put Alice as the first preference, Bob as the second, and Charlie as the third. And essentially, we need to convert these votes into code. So looking at the first voter's first preference as Alice, we need to put this into the global array. So preferences 00 represents the first voter's first choice. So since Alice is index 0 in our candidates array, it will equals to 0. Next, the first voter's second preference will be represented by preferences 01, and since it is Bob, which is number 1 in our candidates array, it equals to 1. So the program should continue doing that for the rest of the candidates and likewise for the subsequent preferences of each candidate. So the program will continue to run through each vote. Okay, so for the third voter, they voted for Bob, Alice, and Charlie. So again, in this case, the first preferences is represented by preferences 20, which equals to 1 for Bob. And likewise for Alice, it would be represented by 0 and Charlie will be represented by 2. Okay, so now that we understand what we're supposed to do, we can actually put this straight into C. So this will be the first function that we'll be working on called vote. So as we discussed earlier on, what we're going to do is that we're going to look through each candidate first and we will check the name key in to see whether it matches the candidate's names. So this is all that we actually need to write for the function called vote. Next, let's work on tabulate. So for this function, we actually want to update the number of votes that each candidate has in the runoff. So at each stage of the runoff, each voter effectively votes for their top preferred candidate who has not already been eliminated. This is a section of the distribution code for us to work on. And to do so, essentially, what we need to do is to check through each vote that was made and add it to the candidate's total count. So we actually need to look through each voter first. So we run through each row represented by I. And then after that, we need to go through each ranked choice of each voter. So we will look through the rankings, which are actually the columns represented by J. So for example, the system will actually look through the first row where I equals to 0. And then it loops through the columns. So when I equals to 0 and J equals to 0, the chosen candidate is Alice, denoted as 0 because she is the first name in the candidates array. So when I equals to 0 and J equals to 1, the chosen candidate is Bob, represented by 1. And next, when I equals to 0 and J equals to 2, the chosen candidate is Charlie, represented by 2. So since we have completed looping through the columns, we move on to the next row where I equals to 1, and we loop through the columns again, and this is what it will look like. So what we've actually just done is to write down the code to tell the system to check through each vote systematically. So now we actually need to count the number of votes. And we must remember that as we go through the rows and columns, we also need to check that the candidate has not been eliminated. So if the candidate is not eliminated, we will add 1 to that candidate's total vote count. Right? And after you do that, we actually need to stop the loop and move on to the next voter's inputs. If the candidate is eliminated, the system will then move on to the next ranked preference of the voter. So let's apply this to an example where we can understand it better. So starting with the first voter, the system will check the first choice, which is denoted as preferences 00. Since Alice is eliminated, the system will move on to the next ranked preference and check preferences 0, 1. So since Bob is not eliminated, we will take it that the first voter is voting for Bob. So we will actually add 1 to Bob's overall vote count. So since we have already taken this voter's vote into consideration, the loop must stop now as we do not want the system to also count in Charlie, which is the third preference. So to do so, we will use break to break out of the loop early and move on to the next voter. So for the next voter, likewise the system will skip Alice as Alice is eliminated, and it will add 1 to Bob's total vote count and break out of the loop again and move on to the third voter. So for the third voter, again it checks preferences to 0, and since Bob is not eliminated, again we add 1 to Bob's total vote count and break out of the loop and move on to the next vote. So to put this into code, this is what we will do. We will put if candidate's preferences ij elimination status is false, this means that they are actually not eliminated. And for this case, we will actually add 1 vote count to this candidate's total vote score. Okay, and once we have done that, we will actually break out of the loop and move on to the next voter. So let's put this in C.
So for this portion, we'll be writing the function for tabulate.
Okay, and that would be that for tabulate. Okay, so now we will work on the third function, that is print winner. What is the criteria for the candidate to be the winner? So they must have majority of the total number of votes. So that is more than half. If no one wins, it will return false. So here's the section in the distribution code that we need to work on. So far with vote, we've actually tracked the preferences of each voter, and then with tabulate, we counted each candidate's total vote count. So now for this function, we just need to tell the system the qualifying factor to win the election and to print the candidates' names. So to do this, we need to look through each candidate's name and check if their total vote score is more than half of the total vote count. So for example, if there are actually 4 voters, a candidate with more than 2 votes will win, and we get this by taking 4 divided by 2. And then if there are 7, the candidate with more than 3 votes will win, and we get this majority number by taking 7 divided by 2. So putting this into C, essentially, if that particular candidate's vote count is more than half of the total number of voters, they will be declared the winner. So this is quite manageable, so let's put this in C.
So for this portion of print winner, we will print the winner's name if they have a majority of the votes. And there you go, this is the portion for print winner.
Okay, next let's work on find min, which is to find the minimum. So for this function, it should return the minimum vote total for any candidate still in the election. And this is the section that we need to work on. So how do we do this? So first, we need to find a starting point as the minimum count and look through each candidate. So we can actually start by setting the current minimum number of votes to be equal to that of the voter count. So for example, if the number of voters is 9, let's start the minimum count as 9 for now. Okay, then we need to look through each candidate. If the candidate is not eliminated and their vote count is lower than that of the current minimum count value, that candidate's vote count becomes the new minimum vote count. So let's apply an example so we can visualize this better. If there are 9 voters, the minimum count, denoted by min count, equals to the voter count. Okay, so let's start by looping through each candidate. So let's have the first candidate as Alice, and Alice is 0 in the candidates array. So her number of votes is 4. So since this is less than the minimum count, which is 9, we update the minimum count to be 4. So up to this point of looping through the candidates, the minimum count is 4. The next candidate, Bob, has 2 votes. So since this is less than the current minimum count, which is 4, we update the minimum count value to 2. So that is the new minimum count value. Moving on to the next candidate, Charlie, he has 3 votes. So since this is greater than the current minimum count, we keep the minimum count as 2. So the minimum count for this election is 2. So let's put this in C.
So for this segment, we'll be looking for the minimum vote count that anyone has. So we'll say that there will be a minimum integer which will start as the voter count. And then we'll loop through each candidate. Yep, and there you go. This is the portion for find min.
Next, let's work on is tie, where we need to return true if every candidate remaining in the election has the same number of votes. So this is a section that we need to work on. So for this, there is actually 2 criteria. The candidate must still be in the election, and they must all have the same number of votes. So how do we actually track this? So in the table below, we can see a scenario where a tie will be declared. So there are 2 candidates left running in the election, that is Bob and Charlie. So you can see that they each have the same number of votes, and that is 2. And do you realize that this actually also equals to the minimum number of votes that any candidate has? So to summarize, it means that to declare a tie, our program needs to count the number of candidates remaining in the election, and also count the number of candidates whose total vote count equals to that of the minimum count. And if they are the same, that means that it's a tie, because it means that everyone who is in the election all have the minimum count as their vote total, which means that they all have the same score, and that is a tie. So how do we code this? You can see that we actually need to keep track of 2 things. The first would be the number of candidates left running for the election, which we can declare it as an integer called eliminate. And we also need to track the number of candidates whose total vote count equals to that of the minimum count, and we will declare this as an integer called counter. So how do we count the number of candidates who are not eliminated? So this is actually quite manageable, so we will actually use if the candidate's elimination status equals to false, which we denote as bank candidates I.eliminated, we can add 1 to eliminate. Next, for counter, likewise if that particular candidate's votes equals to the minimum count, we will add 1 to counter. So let's put this in C.
Okay, so this will be the portion for us to find is tie. Do note that for this top 7, I actually changed it to min, because for the earlier portions of finding the minimum count, I actually used the integer min. Okay, so this part I changed it to min. So we'll say that there will be an integer called eliminate and counter, all starting with 0. Now we will look through each candidate. So now we're going to be keeping track of the candidates whose status is not eliminated. Right. And then after that, we move on. If their votes equals to that of the minimum count, then we will add 1 to the counter. Right. So if eliminate equals to counter, that means that there is a tie.
Okay, and that is the solution for is tie. Next, and we are on to the last one, hang in there, we are going to write the function for eliminate. So for eliminate, basically it means that candidates whose total vote count equals to the minimum count will be eliminated. That means that we change the eliminated status from false to true. And this is actually quite straightforward, so let's jump straight to C.
Okay, so for this section, what we're going to do is that we're going to change the elimination status for the person with the lowest vote count to true. So let's look through each candidate again. Yep, and there you go. So this would be the solution for eliminate, and with that we've actually gone through all functions needed for this. So now let's compile it and give it a try. So we'll do make runoff. Okay, so you can see that there's actually an error here. After eliminated, I should put a true, and they expected a semicolon. There was already one here, so let me just try that again. Okay, so now it compiled nicely. So now I'm just going to put in the example that we are given. And I'll say that there's 5 voters.
Okay, and there you go. That is the solution for runoff. This has been quite a journey with 6 functions that we actually have to work on. So good job you for getting through this. And if you found this video to be helpful, do please subscribe to the videos. That is actually most encouraging, and I will continue to work on the rest of the problem sets. See you in the next video.